Welcome to the video on Chapter 11, Lesson 2, Arcs and Central Angles. This video will cover how a circle's angles relate to its arcs. Let's cover some vocabulary. The central angle is the angle formed by two radii of a circle. In this example, these two radii are creating this central angle. The minor arc is the edge of the circle inside the central angle. The minor arc should always be less than 180 degrees. So in this example here, it's this part of the arc here. This is called the minor arc. It's the edge of the circle inside this central angle. Lastly, the major arc is the edge of the circle outside of the central angle. It should be bigger than 180 degrees. So for this example up here, it would be this part of the circle that is outside of this central angle, and it is much larger than 180 degrees. These arc degrees in measures. The minor arc will always equal the central angle. The major arc would be 360 minus the minor arc, and a semicircle is always 180. Another concept to cover is that of adjacent arcs. Adjacent arcs have one point in common, and their measures can be added the same as angles can. So if I add points A, B, and C onto the circle, then the measure of arc AC will equal the sum of measure of arc AB and BC. So they can be added together just like the angles can be added together. So we can use that fact to help us find different arc and angle measures. Now, before we go any further, I do want to draw your attention to this symbol here. This should have more of a curve to it. I just couldn't find the curve option when I was creating these problems, so I just ended up using what looks more like a caret. But that technically should have more of a curve to it, like that of a circle. So that's just what I'm going to be using here. So this says we're supposed to find the measure of arc LK. So we're looking technically for this part of the circle that is out here. And we learned that the measure of that arc will match the measure of its central angle. So in this case, it should be 50 degrees, just like it's matching central angle. The measure of angle KPM should be 180, take away 50 because of this linear pair that's created here. So 180 take away 50 is going to be 130 degrees. The measure of arc JK, so now I want from here the whole way over here, that will still match its central angle, but that central angle is coming from adding the 84 plus 50 together to get 134 degrees. And then you'll notice that sometimes the arcs will have 3 letters, and that just means, so that tells us what direction we're supposed to go around the circle, because this was just J to K, so it became the minor arc. But when this is JMK, it wants us to go this whole way around and find the measure of this major arc. So when we're doing that, finding the measure of the major arc, we're just going to take 360 and subtract the measure of the minor arc that we just found above for 134. So that's going to equal 226 degrees, using the fact that this measure of this major arc is going to equal 360, take away this minor arc. Last one is the measure of arc JM, so that's this piece over here. That again will match the central angle inside, and so I kind of went like this because of this idea again of the linear pair. So all I really have to do is 180 take away 84 from this linear pair, and that will equal the measure of that arc, which is 96 degrees. Another theorem dealing with circles, arcs, and angle measures is that in a circle or in congruent circles, two minor arcs are congruent if and only if their corresponding central angles are congruent. So in this example, we have one circle, so it says in a circle. This is one circle with two congruent central angles. So this theorem simply says that the measure of this arc is congruent to the measure of this arc here. And this is what it looks like visually for two congruent circles with the 45-degree angle measure in there and central angle measure in here. Would say that this arc is also congruent to this arc. All right, so in this final example here, it says in circle K, A, E, and B, C are diameters. And what I want you to realize here is that these are two straight lines that are intersecting at one point. So let's just look at A, E, and B, C. And I haven't even read the rest of the statement, but the only thing I do want to draw your attention to, especially in relation to the theorem that we just talked about, is that this angle is congruent to this one. So AKC is congruent to BKE by vertical angles here. So let's review back to those angle relationships. Those are congruent angles by vertical angles. So technically, the last theorem would then take us a step further and say that this arc BE is congruent to the arc AC. Now we may or may not find that useful in this particular problem, but that's ultimately what that last theorem was saying. So let's get back to this. It says the measure of angle AKB is 130. So I'm going to put 130 right on top of the K because it's over here, AKB. So it's this larger section over here. And it says the measure of arc CD is 25. So technically I'm going to put that out there, but because of the relationship with arc measures and their central angles, I can also put the 25 inside. And so our first task is to find the measure of arc CE. So that's going from C the whole way around to E. And so my fastest way to use this really, or come up with this, is going to be this linear relationship here. I'm going to go ahead and fill in what that blank is. So that should be 50 degrees over here. So it's also going to be 50 degrees here, and hopefully that moves things a little bit faster. And actually I'm going to go ahead and figure out that this one inside of here is 105 degrees. Again, just using linear relationships in there. But that would also then be able to allow us to set up a relationship with the arcs also. So back to where we were. So from C to E, I can go ahead and take the 25 and add it to the 105. You could also take this 180 from this semicircle and subtract the 50. We might even recognize here that we have, again, the vertical angles with A, E, and B, C, not with the 50, but with the 130 degrees. So this 130 degrees over here is congruent to this 130 degrees here. So the measure of arc CE ends up being 130 degrees for several reasons. And finding DE, well, I already did that when I was filling out in the rest of these missing angle measures using the linear relationships. So the measure of arc DE is going to match this central angle in here, which is simply 105 degrees. And that concludes lesson 2 from chapter 11 on arcs and central angles. So how are a circle's angles related to its arcs? The central angle has the same measure as its minor arc.